need it. All right. Yield curve strategies. Now, if we move to the next example, so what I just did is I did blue box 16 and blue box 15. Now I've got blue box number 1. All right, so let's come down here. And this is this in the intro, yield curve strategies? Blue box 1. Okay. So if you come down here, it says, I've got an active bond manager, has 2 different portfolios, a 50 million portfolio. Portfolio A is in a bullet, 100% in a 5-year bullet bond. And then portfolio B is a barbell. I got half of it in a 2-year, half of it in a 10-year. Both are duration matched. So they both have exactly the same duration. So what we're basically saying is we're taking it down to the convexity statistic. Okay. How do the portfolios value when the yields change by 50 basis points? Now here they're just saying a generic change, not up, not down, but they want you to do both scenarios. Okay, so notice the 2 and the 5-year, I'm sorry, the 2 and the 10-year are the barbell, the 5 is the bullet. So the bullet duration is 4.88. What I need to do is I need to figure out what are the weights on the 2 and the 10 to get a duration neutrality. Because what that does is it basically eliminates the duration component from our equation. So come down here, I have to do a linear approximation. So I'm going to take the 4.88 on the 5-year duration and equal to 1.994, which is the 2-year duration times X, plus 9.023, 1 minus X. So when I multiply these through and then isolate X, I find out that the 2-year weight is about 59% and the 10-year weight is around 41%. So then when I actually put those weights on those 2 and 10, then I have exactly the same 4.88 duration as the 5-year bullet. Okay, now they go through scenario analysis. So what this is going to do is going to say, all right, well, wait a second. If I'm duration neutral and I look at my expected return on a bond and I take out the change in rates given modified duration, and if both the bullet and the barbell experience the same up or down, then it's really going to fall to the convexity statistic. And you're probably going to be right. It's all about the convexity in this example. So if you look at the bullet, I've got a negative duration, 4.88 times a rise in yield. So it's positive. Okay. Now, if you go to the barbell, you've got the weight of the barbell, 0.5894 times a negative modified duration times a rise in yields. Look at the next box over. I have the weight 41 times a negative 9.023 times a rise in yields. If you looked at those 3 boxes that I have highlighted, you'll find out that they're basically neutral. They're exactly the same. So what it comes down to is the convexity statistic. But if we went ahead and calculated equation number 4 through this, the bullet, the duration plus the supplement convexity of 1/2 times the convexity statistic times the change in yield squared, a bullet had a loss of 2.4. And if I look at the barbell, which with duration neutrality had greater convexity because it's a 2 and a 10, greater spread and dispersion, the loss was only 2.4 or 2.39. So either a $1.2 million loss or a 1.194 loss. So on a percentage basis, it looks very close, but on a dollar basis, on $1 million or $50 million portfolio, it's a little bit larger. So a barbell that has greater convexity when interest rates went up had less of a loss. And then if you do the same calculation point on the barbell and you go through the same calculation, you find out the barbell makes more than the bullet. So when interest rates are volatile, you want greater convexity. And that convexity can come from longer maturity bonds. It can come from a barbell strategy. It can come from a ladder strategy. And those structures, when there's interest rate volatility, and in this case, they said yields are changing, they didn't say up or down, and it doesn't really matter, the larger convexity portfolio is going to outperform. Okay, now with those fundamentals under our belt, we're now going to go into the scenarios: stable, parallel shifts, steepening and flattening, and then curvature and volatility. So now we're looking at, all right, with blue box 1 behind us, and look at question number 2. Blue box 2 says, portfolio convexity is a second order effect that causes the value of a portfolio to respond to a change given a change in yields in a nonlinear manner. Which of the following best describes the effect of positive portfolio convexity for a given change in yields? And if you look at answer C, it says convexity causes a greater increase in price for a decline in yields and a smaller decrease in price when yields rise. That is the definition of convexity right there. Okay. So now in section 3, yield curve strategies, static. So it says there are ways in which a manager can actively position a bond portfolio versus the benchmark, active management, to generate excess return from a static or a stable yield curve. And that is to increase risk by either adding duration or leverage to the portfolio. Notice this in green. If the yield curve is upward sloping, longer duration will result in a higher yield because of the maturity premium. Repo trades will also add additional excess return. Okay, so come over to my slide. I need you to know the 4 ways that in a static interest rate environment, how can I add value to the client? Well, the first one is just a buy and hold cash trade. Now, why am I saying cash trade? Because it says that I'm using cash-based instruments. I'm buying a bond, not a derivative. I'm not buying futures. I'm not doing a repo. I'm not doing a swap. I am buying a cash bond. And if you notice in my slide, number 1, active buy and hold is a cash trade. A repo, should be a cash trade. And a rolling yield is a cash trade. But a derivatives position, such as a swap or a futures, is not a cash bond trade. It's a derivatives use. So there are 5 different ways to add value to a client. 3 are cash-based, 2 are derivative-based. So the first one is, I look at a benchmark and I see its duration is 4. Now we know that when interest rates move, it creates a change in the bond price, right? But if interest rates are stable, how do I add value to the portfolio? I'll go a little bit longer term cash bond that has a duration of maybe 4.2 or 4.5. And by doing that, I get a little extra income, longer maturity bond, which then creates a premium, or not a premium, but an extra added value component when nothing's changing in the marketplace. I earn a higher yield to maturity. And I'm also earning, because it's longer down the maturity spectrum, a possible higher liquidity premium. But because it's a longer maturity bond, I might face a little liquidity risk. Shorter term bonds are much more liquid than longer term bonds, but I earn the liquidity premium and the maturity premium. Now, we've talked about the roll down. As long as the yield curve is upward sloping, I get a positive roll down. If the yield curve is inverted, I get a negative roll. So if the yield curve is static and upward sloping, I go a little bit longer yield or a little bit longer maturity. Therefore, I get a higher yield. So as the bond ages and moves toward its maturity, it shortens in its maturity and the yields are dropping because it's an upward sloping curve. I get a positive price appreciation. And you saw that in the end of chapter question that we had with Victoria Lim, and then you saw it in blue box 15 and 16. Okay. Now remember yesterday in Intro to Fixed Income, I said, what is leverage? And leverage is when you borrow cheap and invest for a higher rate of return. And a repo was one of the 5 ways that we can do leverage. Remember, we talked about a repo haircut, and we talked about all the factors that affect the repo rate. And we calculated what is the interest on a 1-day repo and what the net price of the repo repurchase would be. And so remember, if I say that I have a portfolio of bonds and there's a bond in there that's not giving me income yield or anything else, and the